Welcome back to, I'm sorry to say it, another small project. I know, we should continue with the electronic steering wheel project. Card here, link in the description. And we already had a small project last week where we made that little pointed shaft here for the visual alignment of parts on the scratched lines. However, before we continue with our main project, I need to make, or at least I want to make, another enhancement to my Proxxon milling combo here. Card here, link in the description. You see the Z-axis of that Proxxon milling combo, it can move 70 millimeters, which is quite good. However, what if you want to drill a hole 65 millimeters deep and maybe, counting the tip of a drill, total of 70 millimeters down. And suppose you want to do that in very fine steps, let's say starting with 8 millimeters and then slowly going up to 16 millimeters. At the end in half millimeter steps with the drill diameter. Because officially that Proxxon milling combo, drilling combo, can only drill up to 10 millimeters. So you have to be very gentle with it. But what's even more problematic is that you have to reposition the head on the column each time you change a drill. And here comes the drawback of such a small setup. That head can freely rotate on the column. There is absolutely no guide. So if you move the head up and down, chances are you lose your position here on your piece. And that's the problem I want to solve today, or at least try solving it. Anyway, enjoy! This is Robert from the future. As it turned out, this video will mostly be about taking measurements on awkwardly formed parts in awkward positions. So you might be able to learn something about that at least. The quick and dirty solution that for that problem I came up is to scribe a line here along the length of the column and then have a little notch here where the head is attached to the column, so you can always align rotation-wise the head to the line to the head. So hopefully you won't get any error wiggling that left and right here while moving it up and down. At least that's the idea. Now to scribe, and I took the head off already, scribe a reasonably straight line at the radius, not a wobbly line and not a diagonal, but really a straight line on the column. We first have to get that column parallel to a surface. Now I could take the column out of the machine, but then we are back at step 0 of tramming the whole thing, and I want to avoid that. So we just try to fix that to my trusty flat plate, old kitchen top, and then we go from there. The first really undesirable thing I noticed here is that when we set the whole thing here on that surface, it's not really stable. So first things first, we will shim that from the left and the right until it's no longer wobbling. There. And now I'm going slowly but surely through my parallels to find a pair that will support here the end of the column. So it's exactly at the same height here at the top as it is on the bottom. Now this could be a tedious task, but there is a little trick. You see, when you have two parallels here at the back, and the parallels are too high, that is, we are still leaning downwards here, then the front parallel will move freely, while the back parallel, it's taking on all the weight of the column. So that's the first rough indication if we are really parallel to our surface. That is, the column is parallel to our reference surface here. Reference surface, kitchen plate. The pair of parallels before were 26 millimeters and these are 22 millimeters, and you can still see, the front one here is moving freely. So we go even smaller. We're down from 22 to 18 and now, that parallel, takes all the load and that one can move. I mean, not really move, but it can move. That means we can now shim slowly but surely until both parallels are, taking the weight of the column. I rearranged everything a little bit closer to, or quite close to the edge now of the desk, so I can clamp down here if I need to. And I have the first clamp here also in place. Just, this is heavy and just resting on a very small surface. I also moved the shims here a little bit in and out to adjust the height here. Remember, that edge here, it's, a little bit curved. So the further you get together with these shims, the more you lift that up, and the further you go, go outside with the shims, without it still not being rocking, the lower the whole thing comes. And with all that fiddling around, and I'm using that surface here of the caliper to go onto the desk, we're now here at the front, or at the top at... It's a bit hard to measure that around the camera, but 49.15. Yep. And you also see there, this is no longer wiggling like crazy. There is some friction on that parallel too, while the other one is still holding the majority of the weight. But at the back, sorry, be probably in the way now, but that's inevitable. Try to make that really parallel here and on a straight angle. At the back we are at 48.55. After a few more rounds of experimenting with shimming, and at the end using actually tin foil for shimming here at the front, and I added more clamps to make the whole setup a little bit more stable. We're now at 49.20. 49.21 at the front. And 49. Sorry, losing it here. 49.2021 at the back. 1920 at the back. I take that. 200ths. I netted another clamp to the front, just so nothing will move. And please note that now both parallels are, firmly pressed down to the table and no longer moving. That is, both parallels take now up the weight or the force exerted by the shaft. So, it should be pretty much parallel to my table, hopefully. Now we're almost ready to scribe a line into the side of our column with the height gauge. However, at which height we should scribe that line is the big question now. I know because I measured it a lot of times before. This column has a 45 millimeter diameter, plus minus 100, depends how and where you measure. Now we measured the height over our surface with 49.21 millimeters. But here, trap for the young players here, that was the distance between that surface and that surface. And that surface did touch the top of our column while it's lying down now on its side. However, that was our other reference surface that rested on the table. So we're missing in the 49.1 millimeters the distance between that surface here and that surface here. We can measure that with another caliper. That one is not as precise as that one. Just when measuring here, make sure that these surfaces here are really parallel. Because otherwise you get an angle here and then you're not really measuring it correctly. So, yep. That's it. And we are at, let me see, 13 point, okay, parallax error. Watch out, sorry, shake cam. 13 point. I'm really sorry about that, but the workbench is full. 13.85, I'd say. Yeah, we are somewhere here. So that's the 8, that's the 5, so 13.85. So we add the 13.85 to our 49.21, and this is, if I did it right, 63.06. So I set my height gauge here to 63.06. And each of the small ticks is 200ths of a millimeter, so 3 ticks up, and yeah, I think I nailed it pretty much. But that was a clumsy, indirect method involving my old calipers. So just as a sanity check, I'm trying now here if I can just go over my workpiece, and no, I'm colliding here. So what we do instead, and we do that blindly. Sorry, you probably can't see that. Let me refocus. I'm getting here a little bit up. Okay, now I'm clearing here completely. So we're going a little bit down again. Still clearing, down again. Still clearing, down again. Still clearing, but we're getting close. Let me zoom in on the tip. Yeah, the goal is here to have the tip just touching. Anyway, we are close. Can I zoom in a little bit further? We are close, but no cigars. So okay, now I'm just touching. I cannot feel it, but I can hear it. Have a listen. It doesn't even really scratch the metal. So yeah, we are now at the right height. And now we can read the result of here. That's 63 point... where's my finger? 32, 34, let's call that 33. So our first result, which was obviously too low, was 63.06. And now with a height gauge, we measured 63.33. So we were 0.27 millimeters off. That's quite a bit, and that happens if, measurement errors add up. All what's left to do now is to take the diameter of our column, 45 millimeters, I already mentioned that, divide that by 2, so half thickness of the column is, or the radius is 22.5 millimeters, and then we subtract the 22.5 millimeters from our 63.33 millimeters, and we will set our height gauge to 40.83, so and either 82 or 84 or a little bit in between. So I dialed in 40.83, hopefully. So we are somewhere between 200ths and 400ths over 0.8. And all that led to this exact moment in time where we can actually scribe the line here on that side, because obviously I have no space on that side. Whew, wish me luck. And now we'll turn that thing around and have a look at the result. Yep, the line is definitely there, okay, but you can of course barely see it. It really depends on the lighting, so we will have to do something about that too. And the first step is to take a paint marker, so not a normal edding, but something that really contains paint, and trying to get some paint into that hole, slot. Okay, that's almost good, but not quite. If you go over it, you can actually feel now a little ridge on both sides of where we scribed the line. We will remove that with a stone. Just taking the stone very lightly here. And feeling if the scratch is still there. And if it is, a second pass. Yeah, that's good enough. And finally, I have here a piece of wood, which, I just put some kitchen tissue around it and some alcohol, and we use that to polish a little bit. And you see the line is getting thinner. Maybe I was a little bit too aggressive. No. The idea is, and you can already see it, that it's much more visible now. The idea is to just have a little bit of, black color at the bottom of the scratch, so it's easier visible. And in the end, you should have a very well defined fine line along the whole column. And yeah, it's a little bit better down here. That looks better, but it's okay. I could take off a little bit more ink at the top, and maybe I'll do that right now. The next step is to create some markings itself on the head. So here through the center of the bore. And we know that the diameter here, at least when it's clamped down, is also pretty much 45 millimeters. So the question is now, how high above our plane surface here do we have to make that mark? And there are basically three ways to measure that. The first way is to measure through the slot, not exactly here at the front, because it's a little bit round, and just go up here until we hit the center and keep everything nice and parallel, and then just wiggle a little bit, and we are here at 62.61, 64, 65, 66. Please note that there are many error sources here. I mean, for one, that wiggle here, that would change your measurement. And also on the other axis, that would lengthen your measurement if you wiggle that way. And if you don't hit exactly the center as the top, your measurement would get shorter. But there is a third error source here. You see, our tip here is square and not really a tip. And so we might miss here a few hundredths on the radius. The second option is to take our blades for inner diameter measurements or for inner measurements and use them to determine the diameter or the distance. And here we come to, I cannot even read that, 62.4748. 62 point, sorry, I'm in the way, 5554, something like that. And the last option is, of course, to just measure here the thickened portion for where the clamp goes through. And there we have to be at the very edge. So this is very error prone here. Oops, sorry. And we come to 17.89. No, I'm too far from the edge. 17.50. Yeah, 17.50. The error source here is, of course, that we are not exactly measuring at that edge, and that we are not really measuring here at the very center, but a little bit offset where, our curve is already rising. So now we've taken 3 different measurements, and for the method number 3 we have, of course, to add 45 millimeters, the inner diameter. And on camera I showed you 62.66, 0.55, 0.50, and in preparation I, without working around the camera, I took some measurements and I came to 62.60, 62.64 and 62.58. So 3 different methods, 2 measurements each, all a little bit different, within a few hundreds, plus minus a few hundreds. What do? You take the average. Or if something looks really totally off, you throw that measurement away and take the average of the rest. Our measurements average out at 62.57, 1666 or something. Then we have to subtract half the diameter of our hole, and that gives us a height of 40.07 over our surface, where we have to scribe the lines on the head. I dialed in, where's my little finger, 40 0.07, so between the 006 and 008 mark here on the dial gauge. I hope I did that right. And yeah, now we do some scribing. The height looks about right, so I just do 2 light scratches here. And now we first sand off the green paint here around these spots, because I want a black line on a metallic background and not a black line on a dark green background. And now we scribe again, but with a little bit more force. Wonderful. As before, we fill the scratches up with some ink. We remove any burrs we created. And you can already see the line. Yeah, perfect. And the other side too. Not that we need it on the other side, but yeah, 2 nice little lines. Yeah, and some tissue and alcohol to take care of the rest. Oh, I think that was too much. Or was it? Let's see. Yeah, on one side it was too much, but I still have here, that's the side that counts. I have that little black thing. So yeah, I took off too much, but yeah, that's okay. That's enough. And I can always touch up these markings if I need to. That was superfluous anyway. And now we should be able to zero the angle of the head around the column, quite accurately. So I almost hit it. Yeah, we're a bit off, but I can, hammer the whole thing. Until it's perfectly aligned. And of course, afterwards, we torque it down to the max, so the head really can't move anymore. And after torquing down the screws on the head, we'll just make sure that really everything is still aligned, which it is, which is a good sign. That's it for today. Just a, very tiny enhancement to my Proxxon milling setup. Next week, I think we'll continue with the current project. Till then, bye.